In less than 48 hours, Europe's most advanced artificial eye will pierce the deepest mystery of our solar system. This isn't just another observation. ESA's JUICE probe is about to lock onto an impossible object. 3I Atlas, the interstellar comet that by all logic should never exist, is about to be X-rayed at its most secretive moment. Scientists aren't talking, the data is sealed. But right now, something is set to happen that could change everything we know about the universe. Is it a comet, or something that no telescope has ever witnessed? In just 2 days, we might rewrite the laws of science. Keep your eyes on the sky and drop your wildest theories in the comments, because we're witnessing history together. If JUI sends back new data this week, you'll hear it here first, so if you want to catch every cosmic update about 3I Atlas, make sure to like this video and subscribe. 3 weeks ago, a discovery shook the halls of observatories worldwide. Atlas, a 33-billion-ton space visitor, was confirmed as the third object ever seen to wander into our solar system from outside. From the start, Atlas shattered predictions, refusing to play by nature's rulebook. Its path was impossibly precise, carved into the traffic lanes of the planetary highway, the ecliptic plane, a razor-thin slice of the celestial sphere where the planets orbit like coins on a spinning disk. Most interstellar objects arrive from wild directions, their trajectories steep, unpredictable. Atlas was different. It slipped into line with minimal deviation, its orbital inclination within 5 degrees, a cosmic bullseye. Planetary scientists ran the odds, the chance of such a path emerging by accident, less than 1 in 500. For some, it was a statistical miracle. For others, it was the first whisper of something deliberate. Atlas wasn't just a stranger in the right place at the right time. The object's velocity was stunning, 200,000 kilometers an hour, proof it wasn't captured but truly interstellar, the equivalent of a visitor from another neighborhood, speeding through at rates that no local comet could match. On July 1st, the Atlas survey in Chile logged Atlas's approach. The clock began ticking, days counted down to perihelion, the closest point to the Sun. On October 29th, Atlas would pass just inside Mars's orbit, moving so fast it would be, for a moment, the quickest object ever witnessed in the inner solar system. But then, the world went blind. And that's where the mystery deepened. Atlas's perihelion coincided perfectly with a blackout window, a period when no telescope on Earth, nor the Hubble nor the James Webb, could take a direct look. It was as if the play had reached its climax, and just then, the curtains fell. The silence wasn't just technological, it was physical law. Looking at the Sun makes it impossible to see anything nearby. Automated safeties kick in to shield delicate instruments. From October 22 to November 7, Atlas would pass behind the Sun, unobserved, its fate decided in darkness. Before blackout, the anomalies piled up. Chemistry led the parade of irregularities. KEK-2, one of the world's most powerful telescopes, tracked Atlas's emission spectrum. Nickel glared from the readings, intense, focused, industrial, nothing like the scattered light of a dirty snowball. Even more puzzling, cyanide molecules stretched for hundreds of kilometers from the comet's core. Any natural process should mix these compounds. Atlas kept them separate, like rooms in a carefully designed building. As scientists prepared to lose sight of Atlas, debates ignited across labs, forums, and clandestine group chats. Atlas also defied expectations of substance and mass. Most comets, Borisov included, consist mostly of water. Ice ancient, primordial, frozen in the heart of the solar system for billions of years. Atlas, 4% water by mass. It was dry, nearly devoid of the life-giving element that defines most cosmic nomads. The structure and the composition pointed to a different formation story. Maybe Atlas was made near a blazing hot star in a region stripped of volatiles. Or maybe, whispered the boldest voices, Atlas wasn't made by nature at all. The shape and spin fed those suspicions. Photometric measurements, how much light Atlas reflected, suggested it was enormous, bright, and spinning rapidly. Yet when it skimmed close to Mars, the planet's orbit didn't budge. There was no gravitational blip, no tiny flicker of impact, no evidence of mass. A comet that large should pull at planets, even subtly. Instead, Atlas was a ghost big, shining but passing unnoticed as if hollow or empty, a shell, a cosmic masquerade. A.V. Loeb, Harvard's insurgent astrophysicist, sensed the stakes. He sounded the alarm. If Atlas was artificial, perihelion was the moment to act, the moment the Oberth effect came into play. The Oberth effect, an esoteric rule of rocket science, means a burn, a push, a shift made while closest to a massive body like the Sun, gets the biggest payoff. Atlas, hurtling at thousands of kilometers per second, could, if anything wanted, brake, slow, and let itself be captured. Not by accident, but by design. That was the ultimate test. If, upon emerging from the blackout, Atlas was slower, changed, captured by our sun, the evidence would be monumental. But just before blackout, an anomaly disrupted the standard Comet playbook. Atlas developed an anti-tail, jets of material ejected not away from the sun, as every comet does, but toward it. It wasn't an optical illusion, it was real, observed, measured, confirmed. Internal forces seemed at work, as if something inside was dictating the flow, not just solar heat. The anomaly intensified all bets, and for the first time in history, for an object with no threat of Earth impact, the International Asteroid Warning Network, a system built to save humanity from extinction-level events, activated a 3-month emergency campaign. Messages zipped across continents, checklists updated, observation time rescheduled from routine comet to potential engineered artifact. As the scientific drama played out, rivalries flared. Jason Wright, another heavyweight in planetary science, attacked Loeb's theories in scathing blog posts. Wright claimed Loeb misread the images, overestimated the mass, ignored coma blurring for faint objects. Loeb replied that only the truly prepared get ahead of paradigm shifts. Betting markets fueled the drama, shifting odds. 75% said Atlas was natural, 25% gave odds to something else. The days curled into the blackout. Mars orbiters tried risky shots, stretching sensors to catch fleeting traces of Atlas. The data was ambiguous, lost in noise, compressed and handed from one analyst to the next. By the time even a hint of findings could be published, Atlas was behind the sun, invisible, undetectable, unreachable. During blackout, anything could happen: fragmentation, deceleration, wild changes. All the guesses, from chemistry to engineering, would come to a head not in observation, but in the model, what emerged after the darkness ended. Everyone's eyes turned to ESA's JU ICE probe, scheduled for the first post-blackout flyby. Its technology was world-class spectrometers for nickel, cyanide, water, polarimeters for unusual surface scattering, cameras for debris, fragmentation, and anti-tail features. JU ICE carried humanity's best hope for an answer, as the probe prepared to snap its readings and feed the world with data at dawn. 3 weeks after perihelion, the blackout waned. Atlas reappeared, a ghost returning from the abyss. The anticipation was sensational. Journalists, blog writers, scientific teams, even defense analysts waited for the JU ICE transmission. If Atlas had slowed down, changed course, split open, or released smaller pieces, the clues would be there. What the world craved was a reveal. As ESA decoded the numbers, in light, in chemistry, in velocity, a new picture began to form. It started slow. The first readings from JU ICE showed fragments, not chaos, but lines, discrete, deliberate, as if following instructions. Chemically, Atlas was still nickeled, cyanide-rich, dry as ever, but the numbers told a story. Atlas had entered perihelion at breakneck speed. When it came out, something in the data had changed. It slowed down. Then it changed direction. And for 6 days, nothing. Silence. Then the signal came back stronger than before. In those words. First leaked as a JICE mission scientist quote, then circulated across forums, news boards, interviews. The true cliffhanger was born. The science had reached crisis point. A cosmic event had unfolded in the dark, hidden from view, and the aftermath was now unraveling live. The implications were staggering. Had Atlas undergone a maneuver? Had hidden engines fired, or natural forces delivered a jolt unlike anything yet modeled? The post-blackout calculations didn't match normal outgassing. Astronomers checked, triple-checked, published online models, tracked every deviation, every debris pattern. The world's astronomers were now detectives in real time. What does it mean when an interstellar visitor, predicted to slingshot away forever, instead lingers, slows, turns? The question gripped not just scientists, but a global audience. News headlines blared, Atlas's change of heart, the cosmic turn, ESA's JICE faces history. Live streams charted the debate. Was it natural variability or the unmistakable hand of intelligence? The betting odds became memes, cartoons, the stuff of viral clips. All the while, JICE was reprogrammed. Every sensor, every beam to test, verify, refute, or confirm the radical hypothesis. Meanwhile, physical explanations stacked up. Some theorized Atlas was a comet from an unusually metal-rich region, ejected in a way that created a hollow, fast-spinning shell. Others speculated on a natural phenomenon, the statistical outlier, a massive chunk of frozen gas and metal, born and shaped in a rare environment beyond anything we've seen. A third camp drew up the most radical, the idea of engineering, machine logic, intentional design. For them, the clues were patterns in the debris, the perfect timing, the internal organization of chemicals, the anti-tail, the silence during blackout. Science's conservative core, armed with Occam's razor, held firm, demanding more, insisting the test was not what we could imagine, but what the data would insist. As J.U. Weiss worked, the world kept vigil. Ground-based telescopes lined up for the next pass. James Webb prepared high-resolution thermal imaging. Citizen scientists charted occultation campaigns in the southern hemisphere, trading notes and data. Of course, all of this is just my speculation, and no one truly knows what the future will bring. Do you guys think my predictions could actually come true, or am I way off? I'm genuinely curious to hear your thoughts. Let me know what you think in the comments. December 19th marks a real astronomical event. Atlas will reach its point of closest approach to Earth, passing at an impressive distance of around 270 million kilometers. This isn't a guess or a hope, it's a certainty, locked into the orbital data and confirmed by international observatories. Its trajectory has been charted months in advance, so everyone from professional scientists to amateur stargazers is preparing a global watch. As that day approaches, the anticipation is electric. All major telescopes will focus on 3i Atlas, hoping to catch every nuance, every shift, every possible outlier in the comet's behavior. It's a rare opportunity to see an interstellar visitor up close, and never before has such an object been tracked so precisely. The fact itself is a reminder, this close encounter is happening, whether Atlas reveals new secrets or remains just another fascinating comet. But what could happen during this passage? Data from previous months have already hinted at strange phenomena, unexpected increases in luminosity, odd orbital precision, and traces of rare chemical signatures. Atlas has shown signs of non-gravitational acceleration, which could point to outgassing, but some have suggested it's worth looking closer. Could JICER, ground-based arrays, witness shifts in Atlas's speed, or even detect a structural breakup reminiscent of artificial satellites? Might coordinated material streams, subtle changes in brightness, or a persistent tail reversal indicate processes we've never seen in a natural comet before? The excitement isn't limited to the December 19th flyby. Atlas is expected to have another close encounter with Jupiter in March, bringing it within observational range of both the J.U. Weiss and Juno probes. These are real dates in the comet's journey, providing multiple windows for the next big discovery or shock. Each pass could reveal new behaviors, rapid spin variation, fragments moving in synchronized patterns, isotopic anomalies that challenge the history of its formation. Between these waypoints, the tension only grows. Teams preparing observational campaigns know they're chasing an object that already defies expectations. Some believe the flyby will finally let us distinguish between extreme but natural cometary physics and something truly unprecedented, maybe even artificial origin. Others expect valuable but conventional comet data, a rare composition here, a strange tail pattern there, but nothing to rewrite textbooks. Yet, the mere possibility that Atlas could display physics-defying moves is fueling a landscape of speculation, from mainstream science blogs to late-night podcasts, from private message boards to official ESA channels. What will be the consequences if Atlas surprises us with something truly out of the ordinary? How will scientific and public opinion react if JS logs a velocity shift, or if the comet's signal appears to show a change in direction or fragmentation on a scale never seen before? Even if Atlas proceeds quietly along its predicted path without incident, this story will remain one of the most suspenseful and closely watched encounters in space history. So as December arrives, the world watches, partly for the promised data, partly for the chance to witness a mystery unfold in real time. The anticipation is grounded in facts, but driven by possibility. Atlas is coming closer, whether it simply passes by or leaves humanity stunned by a cosmic revelation. Every eye will be on it, every sensor ready, every mind alive with what if.